Hello everyone. Welcome back to Python Challenge for All. Okay, let's see where we were last time.
So let's see. Treasure hunting game one. This was on a single line, one-dimensional version. So let's check the code. The point is that, okay, requirement is treasure is somewhere between 1 and 9, and it's starting from 5. You only hear the distance to the treasure, the distance between you and the treasure, whichever is to the right. So yeah, you use abs function here. You can move either to east or west, and when done, you hit the treasure. So it's like the number guessing game, which we did several times back, right? So let's check the code. So the point is, let's open E4 and connect. Treasure is at this position, which we don't know where, and it starts from the central point. You go, if the distance is 0, break, okay? Otherwise, let the user input to tell the distance and go either east or west, and depending on the input, increment or decrement the position. Okay, otherwise you don't like it. Okay, so let's go on to today's word. Oh yeah, when done, right, treasure was at some point. Okay, so maybe here, maybe we can, okay, maybe we can change this to F and done. The treasure. Okay, maybe we can start with lowercase. That then the treasure was at maybe TPOS. Okay, maybe this is good. Just do it one time. Okay, distance 4. Let's move on to east. Okay, the distance is larger, so maybe we were wrong. Go back to west and continue this several times. 3, 2, 1. Okay, done. The treasure was at 1. Good. So now, yeah, good. So okay, let's move on to today's part. Treasure hunting game on a grid. So grid of roads, and we can move only along the roads. It's like New York, Manhattan. Okay, the treasure is some unknown position in 5x5 grid. So let's see. Let's copy this and make a new box here and paste it here. So we make as we remember, it's like X position and it's like X coordinate first and Y coordinate second. Okay, you know, it's the idea is this. Okay, and the distance is like this, which we call Manhattan distance. Okay, let's do it. So we need two variables to take the position of treasure the same. We don't know where it is. Okay, and also we have upos x and upos y as 5x5. Okay, good. So basically it's the same. So okay, distance calculation. This is just like this. You calculate the difference of t plus x minus y plus x and take the absolute value plus. Likewise, abs t plus y minus u plus y. And this will give the Manhattan distance of between you and the treasure, okay? Distance is 0, okay? Maybe you can write it as t plus x, t plus y, okay? Break. So what? We have, you start from 3 by 3, which is written here. Ah, I see. It's wrong, not 3 by 3. Ah, okay. It says 5 by 5 grid. So we'll try smaller version, okay? So that it can be easier, okay? And I did said we should start from 3 by 3. Okay? And then I have calculated the Manhattan distance to the treasure. You can move either of the 4 directions, north, east, south, and west. So here, distance is fine. So east, south, west, or north, whatever. And we need to implement 4 options, okay? If input is east, then what? U plus x should be incremented by 1. Else if input is, maybe we can like if input y plus x should be decremented by 1. And then we need 2 more options. Input is south, okay? Then y plus y should be incremented by 1. Else, input equals north. Y plus y should be decremented by 1. Otherwise, wrong input. Okay. Let's see if this is fine. So maybe we should keep this kind of 3 by 3 this is not so good. So we kind of make 3 by 3. So 1, 2, no. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This should be kept in our mind. And we have either 4 options to move. And then we try to decrease the distance. Okay, let's try it. Or shall we have the y plus y is not defined? Something is wrong. T plus y, y plus u plus x, y plus y. I see. There is some mistake here. Okay. And also, again, maybe we need some cheat information. T plus x, t plus y. Okay. And also that likewise, we need to check the position of u plus x and u plus y. Okay, let's run it. Good. Actually, the answer is at 3, 5. So it's like here, but we don't know. So let's move on to east. Okay. Now the distance is 3. Okay. 1, 2, 3. It seems fine. Okay. Let's go south, north. Distance is larger. So maybe we should go down to south. Okay. Okay, good. South. Fine. Correct. South again. Now we should go west. Done. The treasure was at. Okay, so maybe this is good enough. Maybe we can now comment out the hints and play the game. Good. Okay, distance is 3. Let's go east. Distance is 2. Let's go east again. Distance is 3. So let's go south. Distance is 3. So we were right. So south. Maybe we should go. If we go south, it's big again. So maybe west and north. Good. I hope you can play with it, keeping this kind of grid in mind. Okay. Next, try on a larger grid, like 9 by 9. Maybe you can try it yourself. In that case, you can change this, but it's some troublesome to change this, and this. So maybe we can set the grid size to say NN equals. Let's check. The grid size is NN. Grid size is NN. So here, what maybe we need to divide it by 2 plus 1, because this is good for, in the case it is odd number. Okay, let's do it. Good? Maybe good. West, 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 north, south, 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 east, north. Okay, good. So, okay, by changing this to 9, you can easily try on a larger grid. But try it yourself. Okay, that's all for today. Play with it. So homework, when done, write found at round X. So you know how many guesses we make, you count it. Or hint is that actually we have it here. Use running number I to print how many rounds on how many rounds did we get the right answer. Okay, so next time we'll do this work using total graphics. It should be fun, so please come back. By the way, be sure to subscribe this channel and also give like to my piece. Okay, thank you very much. Be sure to come back. Bye-bye.